I want to do an example of the chi-square test for homogeneity. In an earlier video, I talked about how you would tell the difference between this kind of chi-square test and the chi-square test for independence. And I'll talk again briefly about why this is homogeneity. A sample of females and males are taken to determine if there exists a difference in what kinds of pets each gender prefers to own. The results are shown in the table below. At the 0.05 level, is there a difference in pet preference between males and females? The key to why this is homogeneity versus independence is because we took a sample of females and a sample of males. What's kind of inferred here or embedded in this setup, this stem, is that we have two independent samples and we are testing them against one another. And that is what makes it homogeneity. If instead I took a sample of 500 people and I simply said, tell me two things about yourself: gender you identify as, and what kind of pet you prefer to own, then it would be for independence. But here it says I took a sample of females, I took a sample of males. That's what makes it homogeneity. All right, so our null and alternative for homogeneity, I'm going to kind of fit this in as I can. The null is that there's no difference. And you can word this in a couple of ways. You can say the distribution of pet preference is the same for both genders. You can say no difference in the preference amongst genders. You can say this a lot of ways. I'm going to say the distribution of preference, of pet preference rather, is the same for both genders. And therefore the alternative is that the distribution of pet preference is not the same. Okay, so that would be kind of our state step. Now for the plan, we are doing the chi-square test for homogeneity. And certainly if I were to total up the number of males, I would get 72. And for females, I would get 80. So certainly I could say, well, 72 less than or equal to 1/10 all males, and 80 is less than or equal to 1/10 all females. So I've stated what we're doing. I have condition 1. Now condition 2 has to do with our expected counts. And the expected count calculation is really almost a redistribution of the amount of people you have surveyed, which in this case, I want you to just notice we have total asked 152 people. It's a reallocation of these 152 people amongst the 6 cells. So basically we're setting this up to say how many people like dogs, and then reallocate the number of dog people amongst the 2 genders to say there is no difference. And then we do the same for cats. How many cat people were there? Reallocate to say there was no difference. How many others? Reallocate. Now, the formula to figure out the expected counts, this kind of reallocation, is to figure out the total in each row. So, for example, there were 82 dog people. And multiply that by the number of people in each, the number of people in each column is 82 here. The number of people in the row was 72. To figure out that multiplication and then divide by the total. So the expected count here would be 82 times 72 over 152. And then we would do the same thing for the females. We would say, well, there were 82 dog people, 80 females out of 152. So we'd have to do this calculation 6 times. We don't have to do that. Our calculator will do this for us. But, you would figure out, well, how many cat people were there? In this case, 45. So it'd be 45 times 72 divided by 152. So it is the amount of people in each row multiplied by the number of people in each column and divided by the overall total. Just, again, a kind of proportional allocation of people. Let's come back to that in a minute. Let's run the test on our calculator. Okay, we're going to start by going into the matrices, which is not a place that you've probably used a whole lot, but you go second and then the matrix button on my calculator is on the x to the negative first. And I'm going to put our table into matrix A. So go to Edit, Matrix A. We've got 2 rows and 3 columns. And I'm just going to enter the data as it appeared just like that. There's all of my data. Now, I'm going to go to the Stat menu, go over to Tests, and I'm going to go down to the chi-square test, not goodness of fit, but chi-square right here. And you'll see that it says observed A, expected B. We have put our observed values in matrix A. The calculator is going to calculate our expected values and put them into B. So we don't need to do anything there. I'm going to hit calculate, and here it is. Our chi-square statistic is 4.0595. Our p-value is 0.131, and our degrees of freedom is 2. Let's talk about the degrees of freedom. But before we do that, let me also just go back in here to the matrices and go to matrix B, hit enter, and there are our expected counts. We would want to include this in our plan step. We would want to prove that we know the expected counts all came out. Okay, so I'm going to shrink this down and just, we'd want our expected counts. You would want to essentially recreate this and say they're all greater than or equal to 5. But don't just say you checked them. Write them down. Okay, all right. Now the do, we said that the chi-square statistic was 4.06 roughly. Our p-value was 0.13. I put 2 degrees of freedom. Let me explain about 2 degrees of freedom. 2 degrees of freedom is a calculation based on the fact that we had 3 pet preferences. We do 1 less than the number of categories. That's 2. We had 3 preferences, 2. We had 2 genders that we split amongst. 1 less than that is 1. It is the product. The number of columns, subtract 1, times the number of rows, subtract 1. That's our degrees of freedom. So essentially 1 less than the categories in each kind of split. All right. Finally, our conclude based on this would be the fact that we would fail to reject the null. The reason? Our p-value is greater than the significance level we were told to check at. So, we do not have enough evidence of a pet preference difference between the genders. Essentially, the distributions are the same, or at least we don't have enough evidence that they're different. So again, just to kind of recap all of the pieces here, we knew to begin with it was a homogeneity type of chi-square because we took 2 separate independent samples from separate populations. The fact that it was 2 samples meant it wasn't goodness of fit and it wasn't independence. So the null and alternative is that the distribution of preferences was the same for the genders. If we'd had more categories, we would have said that as well. The alternative would be that they are not the same. We were running a chi-square test for homogeneity. Remember, your two samples need to be checked amongst the 1/10 rule, the 10% rule. Then we did our expected counts. I deleted the calculator, but remember to copy that table down and point out that they were all greater than or equal to 5. Then the do we should be doing on our calculator. It's a little weird because you have to run this test first and then go back and write the expected counts down. But the chi-square test, p-value, remember the degrees of freedom is important. 3 pets, subtract 1. 2 genders, subtract 1. 2 times 1 is 2. It's the product of columns minus 1 times rows minus 1. P-value. So our conclude, we failed to reject the null because the p-value was too big. So we didn't have enough evidence of a pet preference between the genders. If this video helped you, please like and subscribe for more math help.